Assalamualaikum and good days. Hello guys, we are chemical engineering students from University Technology Malaysia. Today we want to share with you about humidification process and its application. Without further ado, let's proceed with the contents. First of all, we need to know what is humidification. Humidification is transfer of water from the liquid phase into a gaseous mixture of air-water vapor. Next, what is humidification process? The process is which the moisture of water vapor or humidity is added to the air without changing its dry bulk temperature. This process is represented by straight vertical line on the psychrometric chart starting from the initial value of relative humidity, extending upward and ending at the final value of relative humidity. In actual practice, the pure humidification process is not possible, since the humidification is always accompanied by cooling and heating of the air. Humidification process, along with the cooling and heating, is used in the number of air conditioning. There are several purposes of humidification, which is to increase moisture content of air, to preserve material properties, to improve process flow, and to prevent static electricity in industry. One of the engineering devices that use the application of humidification process is a cooling tower. What is a cooling tower? A cooling tower is a specialized heat exchanger in which air and water are brought into direct contact with each other in order to reduce the water's temperature. As this occurs, a small volume of water is evaporated, reducing the temperature of the water being circulated through the tower.
Now we will see how cooling towers work. The process started with a warm water from an industrial operation is pushed up to the top of the cooling tower, where the water distribution system is located. The water is subsequently transferred to the wet deck by the cooling tower nozzle. Simultaneously, air is sucked through the air inlet lever, causing the water to evaporate. Next, the heat in the makeup water is eliminated via evaporation. The heated air naturally rises and escapes from the tower. The overall process is carried out in adiabatic operation. Cooling towers are usually classified in the following three ways: fan type, airflow direction, and water circuit. For fan type, there are three types of cooling tower: induced draft, forced draft, and natural draft. For induced draft, a fan located in the existing airstream draws air through the tower. Air is drawn in the intake lever at the bottom and is discharged through a fan at top. In forced draft cooling tower, the fan is usually located toward the basing of the cooling tower and force the airstream into the cooling tower. Natural draft cooling tower do not use a fan. Natural airflow is produced by density differential between heated and cool air. By classification of airflow, cooling tower have two types of airflow: counterflow and crossflow. Counterflow means air move vertically upward through the field counter to the downward fall of water, while crossflow is air flow horizontally through the field across downward fall of water. For water circuit classification, open circuit is All the water flow through the cooling tower come in contact with the air and undergo evaporative cooling. While closed circuit mean primary water does not come in contact with air. Secondary water circuit may or may not be present.
This is some example of industry that use cooling tower: petrochemical plant, natural gas plant, and food processing plant. That's all from our presentation. Hope it is helpful to all of you. Thank you.